Hey, so I'm gonna do like the continuation of the project I did with my previous colleague Ignacio. It's a 3D model of the drivetrain system for a high energy efficiency vehicle. I'm gonna talk a little bit more about the competition itself. I think this really known brand is Shell. It's a British company that produces hydrocarbons. And they decided to create this competition to test the students from different universities to develop the most efficient car possible. The goal itself is to produce a vehicle that has to accomplish certain guidelines, mainly safety guidelines, and it has to travel the most distance possible with just 1 liter of gasoline. Here in the Hochschule Karlsruhe, we have one team that has been competing since 2011. And in 2018, they got their highest record with 1 liter of gasoline. They traveled 578 kilometers. One of my main tasks here in the project was the developing of the tensioning mechanism. We decided to use a drive belt system. So it's important to have the exact tensioning for it, because if you tense it too much, if you tense it too less, it's not going to work efficiently. And also you need to have a special tension so it centers exactly in the pulley. Here, for example, how it works is we have this L-shaped metal sheet. Here on the top, we have the small pulley, we call it like that. That's where the belt goes on. And pretty much we use a turnbuckle, which is this component right here. You turn it, and it's fixed in one point, and in the other one, you regulate this movement, this linear displacement, which is also held by this hook right here. And yeah, pretty much pulls it downwards, so it tensions the mechanism. Also, we did finite element analysis. For the ones not familiar with it, finite element analysis is a computer analysis that you do in order to prove if the structure will hold, will bear the stresses that you put into it. Like, for example, here we're testing the braking force, which is the highest force that the vehicle will bear. And we can see here more or less with this video the representation of how it should behave. And in the next slide, we have more details about the numbers. So the maximum stress was around 75 megapascals, and the plastic deformation of steel starts at 210. So that gives us a minimum safety factor of 2.77, which is acceptable in this case, and we can therefore prove that the structure of the frame will bear the stresses. And that's pretty much it. Thank you for your attention.